Hello, my name is Édouard de Saint-Ours. I'm a PhD candidate in the history of photography at the Universities of St. Andrews in Scotland and at the University of Le Havre in Normandy. And in this video, I'm going to talk about the reception of Edmond Becquerel's incomplete color photography process. Here we go. On the 7th of February 1848, Edmond Becquerel announced to the Académie des Sciences, the National Science Academy in Paris, that he had successfully reproduced the colors of the solar spectrum on a silver plate sensitized in a chlorinated solution. The photographic reproduction of colors had been a desideratum for more than 20 years among pioneers of photography, and since 1839 for the general public in France. But the discovery first passed unnoticed in the press due to a tense political context that would lead to a revolution in Paris only 2 weeks later. The first identified article to mention Becquerel's discovery in the press dates from the month of May 1848. At that time, Becquerel was a laboratory assistant and substitute professor to the chair of applied physics held by his father at the Muséum National d'Histoire Naturelle, the Natural History Museum in Paris. Within his broader research on the chemical action of light, Becquerel developed a color photography process based on the properties of what he called sous-chlorure d'argent. This translates to silver subchloride in English, and it describes a modified state in which silver chloride adopts a purple hue after its exposition to ambient light. The substance had the capacity to reproduce more or less accurately the colors projected onto it. However, even in stark sunlight, several hours were needed to obtain a satisfying image. Becquerel was also unable to stop the photochemical reaction and preserve the colors at the same time. These images photochromatiques, as he called them, photochromatic images, were bound to fade and disappear if not sheltered from light. Discouraged by these limitations, Becquerel set his research aside around 1849 to focus on more promising projects. Neither Becquerel nor Abel Niepce de Saint-Victor, who furthered the research for 20 years after him, were ever able to substantially reduce exposure times or to stop the photochemical reaction. Although the process remained at the experimental stage, it encountered a genuine critical reception, largely conditioned by the public's expectations, the context surrounding the announcement, and Becquerel's own ambitions for his photochromatic images. To understand the reception of Becquerel's process, we must ask certain questions first. What were the expectations regarding color photography in 1848? What did it mean to the public? And were there any precedents? In fact, from the moment that the first photography process was announced in January 1839, the daguerreotype process invented by Nicéphore Niepce and especially Louis Daguerre, color immediately became a desideratum in photographic circles. When Daguerrean plates were first shown, the lack of color often came as a surprise for commentators. How could such a precise reproduction of nature not record its colors? This was not for lack of trying. In September 1827, Daguerre had made experiments with phosphorescent powders, as was recorded by Niepce in a letter to his son Isidore. Niepce also had color on his mind, as suggests a draft he wrote in September 1829 for a book that never came out. In this manuscript, he expressed his intention to dedicate a short appendix to the question of the direct reproduction of colors. Therefore, in the 1820s, Niepce and Daguerre were already looking for a substance capable of imitating natural colors. But the idea of a chameleon substance was first articulated by the astronomer and physicist François Arago when he disclosed Daguerre's process on the 19th of August, 1839, to both the Academies of Science and Fine Arts in Paris. In a footnote to his speech published in the Proceedings of the Académie des Sciences, Arago declared that the way to capture natural colors would be to find one and the same substance capable of reproducing them. He also mentioned the properties of silver chloride already observed by Thomas Johann Seebeck in 1810 and Sir John Herschel in 1839. The quest for this hypothetical substance would dominate the debate on color photography for 30 years. From then on, writers would speak of the problem of color as if photography was an incomplete medium as long as it remained monochromatic. Public expectations regarding color photography led to some confusions. Many scientists, inventors, and enthusiasts attempted to solve this puzzle. As shown by a recent study by John Hurlock, daguerreotypes sometimes show accidental colors between development and fixing. In addition to the blue skies sometimes obtained due to overexposure, this led some to believe that a latent colored impression could be retained. The British scientist Robert Hunt tried to fix these colors in vain in the late 1840s. The public's desire for color photography was also exploited commercially. From the early 1840s on, many daguerreotype studios offered hand-painted portraits for sale. Some even ambiguously advertised color portraits, creating confusion between manually colorized pictures and the photographic reproduction of colors. Several French critics explicitly decried artificial color in photography in their writings, such as Noël Peyman Le Rebours in his treatise from 1843, or Edmond de Valicourt in a manual from 1851. That same year, Jules Ziegler and Francis Vey described in 2 articles for the weekly journal La Lumière the manual colorization of daguerreotypes as vulgar. However, both of them explicitly differentiated this practice from Becquerel's photochromatic images, which, according to Ziegler, were of an immense interest for science and art. For Ziegler and Vey, it was not color itself that was vulgar, but artifice. This discourse went back to Plato's critique of cosmetics in Gorgias, in which Socrates describes the colors manually applied on the body as seductive and deceitful. But a whole rhetoric about the purity of the medium was also at stake. Photochromatic images were nobler than hand-painted portraits because the colors were seemingly obtained without human intervention, which corresponded to the widespread idea that photography must remain true to nature. Becquerel had been a founding member of the Société Héliographique, of which La Lumière was the official journal, so it is not surprising that its writers would promote his process. But it must be stressed that the properties of silver chloride perfectly fit contemporary expectations regarding color photography. In order to understand the critical reception of Becquerel's process, it is important to address their inherent ambivalence, caused as much by the context of the announcement as by Becquerel's hopes for his photochromatic images. Becquerel's process corresponded to the public's expectations regarding photographic realism, but their scientific vocation was much stronger than that of daguerreotype and calotype processes. The scientific potential of the process is first apparent in the context surrounding the discovery. It was announced at the Académie des Sciences by a chemist and physicist who taught at the Muséum National d'Histoire Naturelle. It also stemmed from Becquerel's broader research on the chemical action of light. In addition, Becquerel's first photochromatic images are all photographs of the solar spectrum. That choice was obviously practical, since the spectrum offered a continuous gradation of saturated and constant colors that allowed to compare plates easily, but it was also grounded in contemporary research on the nature of light. The study of the solar spectrum had recently become a whole discipline called spectroscopy. In 1814, Joseph von Fraunhofer greatly increased the resolution of spectral observation by using a diffraction grating instead of a prism to disperse wavelengths. Thanks to that technique, he was able to observe in detail the spectral absorption lines first noticed by William Hyde Wollaston in 1802. Now known as Fraunhofer lines, these would have numerous applications in optics, chemistry, and astrophysics. Although the colors of Becquerel's plates were far from perfect, his vivid spectrum suggested that the process, once perfected, might become a great asset for spectroscopy. It is important to point out that Becquerel's process was all empirical science. In accordance with his father's epistemic convictions, Becquerel valued experimentation over theory and did not try to explain the workings of the process. But his status in the scientific community, his announcement at the Science Academy, and the inscription of photogrammetric images within contemporary research all point to Becquerel's scientific ambition for the process. However, Other elements indicate that Becquerel also foresaw more popular applications for it. First of all, Becquerel was himself a photographer and had already contributed to the technical progress of the medium. In 1840, he discovered that red light could effectively continue the chemical action of more actinic lights, such as blue light. As he demonstrated with this daguerreotype view of the Louvre, red light could therefore reduce photographic exposure times and replace the toxic mercury fumes used at the development stage. In addition, Becquerel was very much involved in photographic circles, being a founding member of the Société Héliographique in 1851 and of the Société Française de Photographie in 1854. Furthermore, the second half of the lecture he gave at the Conservatoire des Arts et Métiers from 1852, entitled Physics Applied to the Arts, and which was a popular success, was partly dedicated to photography. His most important work, Light, Its Causes and Effects, published in 1868, allocated a whole book to photography, where Becquerel wrote that the use of the process in the camera had preoccupied him from the beginning of his research. Another clue can be found in Becquerel's initial announcement from February 1848, where he declared, referring to the limitations of the process, quote, "If this fixation could be realized and the impressionability of the matter increased, not only would one draw, but one would also paint with the help of light." The expression "to paint with light," used 3 times in Becquerel's book from 1868, bears witness to his photographic ambition for the process. By using such fine art vocabulary as draw and paint, Becquerel referenced the metaphor of photography as light drawing, often used to describe the daguerreotype and calotype processes, whether it was by Niepce, Arago, or even William Henry Fox Talbot, who named his first paper process photogenic drawing. By extending this metaphor to apply it to his own process, Becquerel thus inscribed photochromatic images within the short history of photography while announcing the resolution of the problem of color. As if to prove his rhetorical point, Becquerel not only recorded color spectrums, but also copied colored prints, both by doing contact exposures and with a photographic camera. This also suggested that the process could have a future application in the reproduction of artworks. Becquerel chose colorful subject matters that demonstrated his point, and birds were a particular favorite. It is therefore clear that photochromatic images had, from 1848, both scientific and photographic potential. But despite these assets, Becquerel failed to efficiently promote his invention. He readily showed photochromatic images to individual visitors in his laboratory. In 1848, Becquerel showed some spectrums to a journalist from La Presse and lent a few plates to the chemist Jean-Baptiste Dumas, who wished to show them in his lectures. Dumas had been in Becquerel's PhD jury, by the way. He also gratified foreign visitors, showing specimens to the British photographer Thomas Malone in 1850, to the Italian physicist Francesco Zantedeschi in 1857, and even gifted one plate to Michael Faraday that same year. But these visitors were the happy few. Becquerel consistently refused to publicly showcase photochromatic images, arguing that they were too fragile even to the Académie des Sciences in November 1848. In 1949, the rapporteur of the jury of the annual Exposition des Produits de l'Industrie was frustrated that Becquerel had not exhibited any specimens and accused him of having abandoned his research. Becquerel's reluctance to exhibit photochromatic images did not prevent the news from spreading, but the reception of the process differed from one circle to the next. The first article in La Presse from May 1848 was very enthusiastic and praised the artistic potential of the discovery. It read, quote, "Still a bit of effort, and we will see the landscapes of nature, the lively portraits, the works of great masters paint themselves with their 1,000 shades without the intervention of an external brush." Echoing the pictorial metaphor used by Becquerel in the announcement, the author ostensibly opted for fine art vocabulary and imagined that all the limitations of the process would soon be vanquished. 6 months later, another article was published in La Presse about photochromatic images. It was written by the abbot François Moignot, a mathematician who knew Becquerel and had much interest in photography. It was more reasonable than the first article regarding the process's capabilities, but it did not escape the pictorial metaphor. Moigno wrote, quote, "This mysterious layer can really serve as a canvas on which the images of the dark room will be painted in all their nuances," unquote. And later on, quote, "The question of transforming light into an eminently faithful painter or colorist is scientifically resolved, but the artistic solution has so far escaped the incessant efforts of the young and learned physicist," unquote. This pictorial metaphor, however, remained a metaphor. It would have taken much more to enthuse fine art critics, which seem to have utterly ignored the invention, as suggest 1848 issues from L'Artiste and the Journal des Artistes. This is not surprising at a time when art critics still viewed photography as a purely mechanical medium, unable to produce art. Between both ends of the critical spectrum, scientific and nascent photographic circles preferred to underline the theoretical implications of the process. At the Académie des Sciences in November 1848, the physicist Jean-Baptiste Biot, who had been much involved in early debates on photography, highlighted the potential of the process to ascertain the nature of heat and light, thus evoking spectroscopy. In 1851, François-Auguste Renard and Francis Vey mentioned in La Lumière the important impact that photochromatic images would have on color theory, but none of them ventured to formulate any hypothesis as to what this might mean. The following year, another member of the Société Héliographique went further. In his treatise on color and light, Jules Ziegler used Becquerel's photochromatic images to legitimize his belief that, quote, "colors are material and independent from light," unquote. He was wrong, of course, but it is important to know that Ziegler was not a physicist, but a painter, a ceramicist, and a photographer. His color theory was influenced by Goethe and was much more philosophical than scientific in essence. The ambivalence of Edmond Becquerel's photochromatic images therefore enticed a multifaceted reception, but the hopes raised by the process in scientific and photographic circles would never be satisfied. Unable to fix the colors or reduce the exposure times, Becquerel apparently stopped trying to improve the process around 1849. Abel Niepce de Saint-Victor, Nicéphore Niepce's first cousin once removed, would spend the next 20 years trying to solve this puzzle. He did manage to reduce exposure times and enhance a variety of colors on his plates, but was never able to stop the photochemical reaction and retain the colors at the same time. His version of the process, which he called heliochromie or heliochrome, also remained stuck in the experimental stage. Thank you very much for listening to this video, and goodbye.